Welcome to another coding tutorial, and in today's video, I'm going to show you how to make this colorful animation using linear interpolation. Linear interpolation is a method for finding an unknown value based on two known values, and we will be using this method to create this beautiful gradient animation based on two known color values to get the colors in between. There's a built-in function within p5.js called lerp that allows us to use linear interpolation easily, and lerp takes in a total of 3 arguments. The first 2 arguments are the two known values, and then the third one is the amount of interpolation, which ranges between 0 and 1. Let me quickly show you how the lerp function works. I'm going to draw a total of 3 squares using the square built-in function, and the square built-in function takes in a total of 3 arguments. The first 2 are the x and y coordinates of the top left corner of the square, and then the third one is the width and the height. So let's give it 100 by height divided by 2, and let's give a size of 80. Alright, but I actually want these x and y coordinate to be at the center of the square, so I can change the rect mode to center. Alright, let's draw 2 more, and I'm going to give the x coordinates as 200 and 300. Now I'm going to fill in the colors. So I'm going to fill in the first and the third squares with a color of the known colors that I want. So how about first we define C1 to be 255, which is white, and C2 to be 0, which is black. And I'm going to fill the first one with C1 and then the third one with C2. Okay, and then now I am going to use the lerp function to get the color of this middle square. So how about I define this third color as C3, and I'm going to use a lerp function which takes in a total of 3 arguments. The first 2 are the two known values, which I'm going to provide C1 and C2, and then the third argument is the amount of interpolation. And now I'm going to actually set the amount of interpolation to a map function, and I want to map this to my mouse X location between 0 and width, and I want to map to a value of 0 and 1 because the amount of interpolation goes between 0 and 1. I'm going to use the fill function to fill the middle square here with this value. Okay, let's try it. Alright. So when the amount of interpolation is 0, we get the value of 0, and that's why the middle square is white. And as we move the mouse towards width, then the color gets darker and darker until it is black. If I want to not use a grayscale color and I want the color to be, how about red? And actually we cannot use the color function here outside of the setup function. So I'm going to actually declare the variables here and then put C1 equals to color of 255 and C2 as color of 0. So now C1 and C2 are colors, right? And if I were to run this, it no longer works. The lerp function doesn't allow us to use color as arguments. So with the grayscale, it's not an issue, right? Because the value is just one value. But if I want it to be a color red, I cannot interpolate between the color red and the color black anymore. Luckily, p5.js also has another function which does the exact same thing but with color values. That is the function called lerpColor, which takes in a total of 3 arguments as well. The first 2 are the two known color values, and then the third one is the amount of interpolation. So if I click run now and I were to interpolate between these 2 colors, now it's working the exact same way. I can also change the C2 values to be a different color too. Let's do blue. Now that we know how to get an unknown color between two known colors, how do we create a gradient of colors? We can actually do it easily using the lerpColor function and a for loop. I'm going to delete all of this, and then I'm going to use a for loop that goes between I equals to 0 to I less than width, then I plus plus, and then I'm going to copy these, put it inside my for loop. But instead of mapping it on my mouse X location, I'm going to map it to the I value here that goes between 0 and the width, right? And then it's going to map this length here to the value 0 and 1. And then I'm going to draw a line. And the line function takes in a total of 4 arguments, the x and y coordinate of the first point and the second point that once connect together connect to be a line. So it's going to be between I, comma 0, which is the point here, to I, comma height, which is the bottom point here. That goes between x equals to 0 to x equals to width. And then we need to use the stroke color to color the line, and we're going to provide an argument of this color C3. Let's try that. And now we get a gradient of colors, but you cannot actually see this here. But if I were to change this color to, let's say, yellow, it might be more apparent. Can you see that there's a line of light gray here? And that is because actually we need to loop between I equals to 0 to I less than or equals to width. We want it to be until the end here. All right, let's put this set of code in a function. So let's call this function, how about set gradient block. And I'm going to provide a total of 4 arguments. So min, which is the first point, max, which is the second point, and then how about C1 and C2 for the 2 colors that we want to interpolate in between. And then instead of 0 here, it will be min, and then instead of width, it will be max. Min and max. Actually, I'm going to provide 2 more value for the y coordinates. So y and the height. So instead of 0 here, it will be y, and then for height here, it will be y plus height. All right, and if we call this function set gradient block, and then we give it 0 and width, and then 0 and height, and then the 2 colors C1 and C2, we get the exact same thing. But now, what if we want to call it, how about 4 times? And what I want to do is that I want to provide 1 more color, and I actually will set these colors to these colors. And inside these functions here, instead of going from 0 and width, it will be 0 to width divided by 4, and then it will be width divided by 4 to 2 times width divided by 4. So I'm basically dividing the canvas into 4 sections. So now it's 2 times width divided by 4, and then this will be 3, and then for the last one, it will be from 3 times width divided by 4 to 4 times width divided by 4, or the width. And I want to interpolate between C1 and C2 for the first one, and then from C2 to C3, and then I want to go back. So C3 to C2, and then C2 to C1. Click run, and we get this beautiful gradient color. Now I want to show you how to create a gradient in a circle. It's the same logic, so I'm going to use a for loop again, but instead of looping it between 0 and width, we're going to loop it between 0 and 360, which is a degrees of 1 revolution of a circle. And I also want to set the angle mode to degrees because we're using degrees. All right, then now we need to set the amount AMT and map it to I between 0 and 360 to a value of 0 and 1, right? And then we want to set the color C3 to the function lerpColor, provide the 2 values, right? C1 and C2. And then the third argument is the amount of interpolation. And then we want to set the stroke color to the color C3. But now to actually draw a line to make up a circle, we need to use 2 equations that convert from polar coordinates to Cartesian coordinates. And these 2 equations are, let x equals to r times cosine of angle and let y equals to r times sine of angle. How about we first defined what r is, and let's set it to, how about 150? And then actually angle here needs to be this value that we have in the for loop. So it should go between 0 and 360. So we're going to put I here. And then I'm going to draw a line. And this line will go from the center of the canvas to r times cosine of I, or x, and r times sine of I, which is y. So 0, 0 to x and y. Let's click run. All right, we also need to, because we're using 0 and 0 here, which is the origin, we need to translate that origin from the top left corner of our canvas to the middle of our canvas. So we're going to provide the two arguments as width divided by 2 and height divided by 2. All right, and then now we have this gradient color that is in a shape of a circle. And you can also make this increment smaller so that it fills up the color completely. Just like that. All right, how about we put this set of code also in a function? And I'm gonna call this function set gradient ellipse. How about that? And then we need pretty much the same arguments, min and max. We don't need y and h, but we need c1 and c2, right? And then we just copy this set of code, put it inside the function here. And then we need to change 0 and 360 to min and max. And then same thing here. And that should work. Actually, for a circle, we might not need this less than or equals to, because the angle 0 is equal to the angle 360. All right, and so now let's try to call this function. And then set this to 0 and 360. Let's click run. All right, we get the same thing. And now if we want to get more colors into this circle, we can do the exact same thing that we did to the set gradient block functions, right? We can call it multiple times. And it will go between 0 and how about 90. So I want it to go between here to here to here to here. So I want to divide it into 4 sections. 270, then 270 to 360. And we'll change the colors here from C1 to C2 to C2 to C3, and then loop it back to C3 to C2, and then C2 to C1. All right, that looks really nice. But I actually kind of like it to have this a little bit of a grainy look, or not fill in the circle completely. And then how about we uncomment this out? All right, and then let's give this a little bit bigger radius. Before we end this, how about we also move the circle? Let's declare a new variable called angle, and we need to add angle to all of these, right? So basically we want to change the angle at a certain increment, and that increment, how about we set it to 1 at a time. And now the circle is moving at a constant speed of 1 in the clockwise direction. And it looks quite nice already, but what if we can make it a little bit more interesting by using an async function? An async function is a function at which a value is changed. And at a constant speed, an async function would be a function where y equals to x. So we change the value of x at the same rate as y is changed. But as you can see on this website here, there are actually many other async functions. For example, this one, you can look at the thing on the right. It moves at a slow speed and then it goes faster towards the end, where this one, it starts out fast and then it slows down at the end. So there are all these async functions that you can use to get an interesting transition between frame. And all you need to do is click in this link here, scroll down to the bottom, and then you can find these functions. So with a constant speed, the easing function is y equals to x, whereas this one, y equals to x squared. And I've put all of these equations together in an easing.js file so you can check out my code afterwards. Now I'm going to show you how you can use these functions in our code. So all you have to do is come to this arrow here, click the plus sign, and then click create file. Then you want to call this file easing.js, and then you want to copy my code. Alright, so as you can see here, there are all these functions. So for example, this function easingQuad, it returns x squared, right? Before you start using these functions, you need to also go to index.html file, come to this line of code, then copy, and then change the name here to easing.js, and this is how you can integrate the easing.js file into your program. Alright, let's go back to sketch.js. So now instead of changing the angle by a constant speed of 1, I'm going to change it using the easing functions. But before we go there, let me show you how we can use a different equation to change this angle at a constant speed. And that equation is an equation of linear interpolation, which is y equals to min, or the starting point, plus the amount of interpolation times the range, which is max minus min. So basically our lerp function is a calculation of this exact equation. So now what we can do is set angle to be equals to min, and the min is the starting angle that we want to change. So we want to change it from 0 to the range, which is we want to change it from 0 to 360 minus min, which is 0. And with this, we can actually delete the 0 part. So it's going to be the amount of interpolation times 360. And we also want to increment the amount of interpolation, right, between 0 and 1. So how about, first comment this out, how about we set that amount to 0, start it out at 0, and then we write a conditional statement that says if the amount is more than 1, then we set it back to 0. Else, we want to increment it by, how about just 0.01. And then let's click run. And then now it's still the same movement. The circle is moving at a constant speed in the clockwise direction. What makes it interesting is now we can actually use the easing functions that we have defined and give the amount of interpolation as the argument. And it will still return a value between 0 and 1. And instead of just timing the value that is incremented at a constant speed of 0.01, we now increment it by a different speed. So for example, let's do easingQuad, which returns an amount that is multiplied by itself, right? And if you click run, you can see it starts slow and then it ends quite fast. Actually, instead of moving it at a 360 increment, I'm going to change it to 90. Alright, so another thing that we need to change is that we want to give it a new starting value. So let's set a starting angle at 0, and then here we're going to put starting angle plus easingQuad times the amount, right? And then we want to set starting angle plus equals to 90. So every time we goes through one loop of the amount of interpolation, we want to reset the starting angle to be at the new location. So let's click run. So I set 90 at 180, 270, and 360. And there you go. This is how you can create a beautiful gradient using the lerpColor functions. And now you can also create an interesting movement using different easing functions. Give it a try.